The story of America's 90mm gun did not begin in smoke or thunder. It began in silence, inside gray, echoing workshops where engineers measured the sky with pencils and calipers, trying to imagine a weapon that could strike something they could barely see. In 1938, as storm clouds were gathering over Europe, U.S. Army ordnance officers realized that the old 3-inch anti-aircraft guns that had once guarded coastal batteries were dinosaurs. Aircraft were climbing higher every year, bombers heavier and faster, their skins riveted with ambition. The Luftwaffe had not yet darkened the skies of America or Britain, but anyone reading the reports from Spain or the whispers from Berlin knew what was coming. "If war comes," one engineer at Watervliet Arsenal murmured during a late-night meeting, "we will need a gun that can reach the unthinkable." Thus began the race to build a weapon that could hurl steel to over 30,000 feet, a spear aimed at the heavens. The first drawings were conservative, a longer barrel, bigger breech, new recoil system, but the designers quickly realized that they were stepping into entirely new territory. They were planning not a bigger gun, but a different kind of gun, one that could predict where a plane would be, not where it was. Early prototypes fired beautifully in ground tests, but anti-aircraft gunnery was a merciless discipline. Hitting a fast-moving aircraft at 10 kilometers required more than a long barrel. It required mathematics. It required timing fuses accurate to milliseconds. It required a brain. At the time, American gunners still used optical coincidence rangefinders and slide rule calculators. Against slow biplanes, they were adequate. Against a modern bomber flying 300 miles per hour, it was guesswork dressed up as doctrine. At Aberdeen Proving Ground, the first 90mm gun, later designated M1, was test-fired in 1940. The gun bucked like a living thing, sending a shockwave across the range. Shells arced into the upper atmosphere, small glints of silver that disappeared into cold blue nothing. Engineers watched the vapor trails and imagined them bursting into the path of a Heinkel or Dornier. The weapon could reach the heights they demanded. What it lacked was the ability to know when to fire. In those early years, before radar matured, the 90mm was a spear without a hunter. Gun crews drilled endlessly, guessing lead angles, adjusting elevation by instinct, practicing the dance of loading and tracking. They trained in rain and frost, under the glow of barracks lamps at night, aware that one day they might defend cities whose names they did not yet know. One sergeant recalled his first impression vividly. It was tall, thin, mean-looking, like it wanted to stab the sky. Then came December 7, 1941. Pearl Harbor burned, and overnight the slow grind of development became a sprint. The United States was at war, and the Army Anti-Aircraft Command demanded batteries for every major industrial center: Detroit, Los Angeles, New York, Norfolk. The 90mm gun, once a theoretical tool, now became the backbone of Homeland Defense. Perhaps the Japanese would cross the Pacific with bombers, perhaps the Germans would send raiders. No one knew, but the 90mm guns were planted like iron teeth around the coastlines. In those months, American fear and American ingenuity collided. Laboratories accelerated their work, new proximity fuses were tested, prototypes of the SCR-268 radar provided crude range information, and in dusty warehouses, an early version of what would become the M9 ballistic computer hummed and clicked through equations too fast for human gunners to calculate. Engineers dreamed of uniting these elements, gun, radar, computer, into a single killing system. But in 1942, such dreams were still smoke. Crews deployed with their guns, but without radar guidance. They trained by tracking clouds and imaginary planes, moving the barrels silently while officers called out simulated bearings. Yet even without its future electronics, the 90mm immediately showed promise. It was accurate, rugged, and more powerful than any American anti-aircraft gun before it. In live-fire exercises over the Gulf of Mexico, practice drones found themselves shattered or crippled by bursts far above the waves. One observer described watching a salvo reach its peak altitude and explode in perfect symmetry. It looked like a silver halo forming at the edge of the world. By mid-1942, the 90mm M1 was deployed overseas for the first time. Crews set them up in sandbag pits across North Africa, their barrels pointing toward skies buzzing with Luftwaffe reconnaissance planes. Without radar, the guns relied on sound locators and spotters, old tools in a new war. But even so, German pilots reported something strange. Previously, they had flown at altitudes they believed safe from American flak. Now black bursts were blooming far closer than expected. In one intercepted German message, a pilot warned, "The Americans have a new high-altitude gun. Do not underestimate its reach." They were only seeing the beginning. The true transformation, the one that would make German pilots gasp in disbelief, lay just ahead, in the arrival of radar SCR-584 and the M9 Director. These systems would turn the gun into a thinking weapon, one that could strike the sky with machine-guided precision. But Part 1 ends before that revolution. Here, in 1942, the 90mm stands as a promise and a threat, an iron spear pointing upward, waiting for the moment when war in the sky becomes a war of mathematics. The Germans still believed altitude was safety. They had no idea how quickly that illusion was about to shatter. By the time 1943 dawned, the 90mm gun had muscle, but not yet a mind. It could throw steel higher than any American gun before it, but the problem of hitting something at those heights remained maddening. To strike a bomber at 25,000 or 30,000 feet, a shell had to meet it in the air at exactly the right moment, at exactly the right point, a three-dimensional intersection calculated in fractions of seconds. Human gunners could estimate, approximate, pray, but they could not match machines. Not yet. The solution arrived in the form of two inventions that looked unimpressive on the outside, a fat, rotating dish called SCR-584 and a humming, clicking metal box known as the M9 Gun Director. Together, they would transform the 90mm gun from a high-altitude brute into the most advanced anti-aircraft weapon of its time, a system so sophisticated that German pilots believed it was seeing them, stalking them through the clouds. It began with the radar. SCR-584 was different from earlier sets, smaller, smarter, and astonishingly precise. Where older radars could only guess a plane's distance, the 584 could track it automatically, locking onto a target and following it across the sky like a predator. Its rotating antenna swept the darkness with pulses of radio energy, each ping bouncing off metal thousands of feet above and returning with information: distance, direction, speed, altitude. Inside the operator's van, the screen glowed a ghostly green. A blip would appear, faint, then bright, and the operator would lean forward, hands poised over the controls. "Target acquired," he'd say into a headset, locking on. And once the radar locked, it stayed locked, even if the target dived into cloud banks or slipped behind hills. But seeing the target was only the first half of the miracle. The second half was predicting the future. That was the job of the M9 ballistic computer, a mechanical brain built of gears, cams, and spinning disks that turned raw numbers into firing solutions. It looked like nothing more than a heavy metal cabinet, but its guts were a symphony of engineering. Radar operators fed it data through cables. The M9 digested the inputs, calculated the target's trajectory, and issued commands to the guns: elevation, bearing, fuse timing. To a gun crew of 1943, it was nothing short of sorcery. One gunner from the 209th AAA wrote in his diary, "We don't aim anymore. The machine does. We just follow orders from a box." And the box was astonishingly fast. A Luftwaffe bomber flying at 320 miles per hour gave the M9 all the information it needed, allowing 90mm guns to fire not where the bomber was, but where it would be in the next few seconds. For the first time in American history, artillery was firing at coordinates that did not yet exist. When tested together at Fort Bliss in late 1943, the combination of SCR-584 plus M9
plus 90mm guns achieved something previously thought impossible: consistent hits on aircraft flying at over 10 kilometers altitude. During trials, observers watched in disbelief as drones were shattered mid-flight with accuracy so sharp it felt unreal. One officer, shaken, remarked, "It's like the gun knows where to shoot before we do." Word spread quickly across the army. A new age of anti-aircraft warfare had begun. What had once required guesswork and perfect weather could now be done in fog, rain, or total darkness. The radar saw, the computer thought, the gun killed. By the spring of 1944, full SCR-584 batteries were being deployed to Europe. American crews trained with an intensity usually reserved for fighter pilots. They drilled radar acquisition, rapid target transfer, and coordinated firing. A 90mm battery with radar became something entirely new: a machine-linked organism. The process moved like choreography. Radar locks target. M9 computes firing data. Fuse setters spin time fuses to the millisecond. 90mm guns elevate automatically via power drives. Battery commander calls fire. Then, a synchronized eruption of thunder. Shells screamed upward in perfect arcs. At 20,000 feet, timed fuses burst, creating expanding spheres of shrapnel at the exact altitude and airspeed of the incoming plane. German bomber crews could hardly fathom what was happening. Reports from the Luftwaffe describe a weapon that seemed almost supernatural. "The Americans have a gun that follows us even when we cannot see the ground. Their flak is bursting at our exact height every time. It is impossible to escape."
The first V1 arrived over Antwerp just past midnight. No roar of engines, no formation of wings, only a buzzing, feral hum that rolled across the rooftops like an angry insect. To the people below, it sounded almost absurdly small for a weapon of war. To the American and British commanders gathered around the Antwerp docks, it was the sound of impending catastrophe. If the V1s got through in numbers, the port, the lifeline of the Allied advance, would be strangled. Eisenhower's armies would starve of fuel, ammunition, and men. Antwerp had to be protected. Thus began Antwerp X, the most sophisticated anti-aircraft defense grid the world had ever seen. At its heart stood the silent giants. The American 90mm guns, guided not by men alone, but by radar, computers, and the cold precision of physics. The first bombardment stunned Allied intelligence. Germany was launching hundreds of V1 flying bombs from positions in the Netherlands, sending them arcing toward Belgium at over 400 miles per hour. They flew low, fast, and unpredictably. Fighters had trouble intercepting them. Conventional AA fire burst behind or below them, and their warheads, nearly a ton of high explosive, could flatten warehouses, sink troopships, or detonate among packed supply yards. But the Americans had an answer, and it was already being unlimbered in muddy fields outside the city. Radar SCR-584 vans, M9 ballistic computers, rings of 90mm M1 and M2 guns, dozens of AA battalions, eyes fixed skyward. When the first radar-guided battery opened fire, it changed the course of the siege. The first kill. It happened at dawn. The radar screens glowed with a jittering blip approaching from the northeast. Bogey incoming, speed 350, altitude 1,800 feet. The operator nudged the tracking servo. The dot steadied. Seconds later, the M9 computer hummed into life, gears spinning, relays clicking like distant insects. Barrel angles shifted automatically. Fuse setters cranked their dials. "Battery ready," the commander whispered. The V1 came into view. A flicker of wings, a pulsing exhaust flame. It moved like no aircraft they had ever seen, stiff and relentless. Fire. 4 90mm guns spoke as one. Shells cracked the air, climbing into a precise envelope of sky. The first burst missed, but the second blossomed perfectly in front of the V1. Shrapnel tore through its thin skin. The flying bomb hiccuped, lost speed, and dipped like a puppet with its strings cut. Then it exploded. A dull orange fireball lit the horizon. Men in the gun pits exhaled for the first time in minutes. Someone laughed. Someone else muttered, "Jesus, it actually works." The first kill was followed by dozens, then hundreds. building the skywall. By late September 1944, Antwerp X was fully operational, a 360-degree shield composed of interlocking radar-guided batteries. Each gun position fed radar data to a central command post. When one tracked a target, others aligned for crossfire. The grid learned, predicted, and reacted faster than any human could. V1s came screaming over the horizon. The radar picked them up. The M9 solved their future. The 90mm guns destroyed them. Day after day, night after night, fire and math fused into a lethal rhythm. Crews became specialists in killing things they never truly saw. The V1 speeds were almost too fast for bare eyes. Operators often fired at icons on a radar tube, trusting the invisible hand of electronics to guide their steel. Veterans later recalled the eerie sensation of battling ghosts, weapons that could not fight back, flying straight into the jaws of an automated trap. In one 24-hour period, an American AA group shot down 91 V1s. In another, the British and Americans combined for over 100 kills. Even Luftwaffe observers were stunned. A German intelligence report captured after the war stated, "The American 90mm with radar control has become the most effective anti-aircraft gun in the world. Our flying bombs cannot defeat it." Inside the gun pits. Life for the crews was brutal. Antwerp in 1944 was cold, wet, and under constant attack. Radar vans were placed in open fields, their crews soaked by rain and blasted by icy winds. Inside, the glow of the cathode ray screen painted their faces green. Outside, the guns thundered so violently that the earth trembled beneath their boots. Gun crews slept in bursts of minutes between alerts. Some stood watch for 36 hours straight. The V1s didn't come in neat waves. They came whenever German launch crews upstream managed to fire them. Gunners wore cotton in their ears and grease on their hands. Few setters worked with blistered fingers. Radar men lived under stress that could not be described. The constant buzz of the magnetron, the pressure to track a target whose arrival meant death for thousands. And yet there was pride, fierce pride. One battery commander wrote in a letter home, "We are not fighting men. We are fighting machines built to kill civilians, and we are stopping them." The pilot's perspective. Though the V1s carried no pilots, other German aircraft still roamed the Belgian skies. Ju-80 Night Raiders, Me-410 Intruders, and even Me-26 jets testing Allied defenses. These pilots quickly learned what the V1s had taught. The 90mm guns were no longer blind. At 20,000 feet, they expected to be safe. They were not. One Luftwaffe pilot described his terror in a post-war interview. "We were above the clouds, above the searchlights, and suddenly, black bursts appeared directly in front of us. Not below, not behind, directly ahead. It was impossible. It was as if the Americans were reading our minds." SCR-584 had locked onto him without mercy. The M9 had predicted the exact point of interception. The 90mm had delivered. He barely survived. Victory in the Sky War. By early 1945, the numbers were staggering. Over 14,000 V1s launched in Antwerp. More than 12,000 intercepted or destroyed. Most of those kills credited to radar-guided 90mm guns. Never in history had artillery achieved such precision at such altitude and speed. The Germans had hoped to flatten Antwerp. Instead, they had flown their deadliest weapons straight into the greatest air defense system ever built. And it had been built not by engineers alone, not by soldiers alone, but by both, a fusion of human resolve and electronic brilliance. The 90mm gun had become more than a weapon. It had become a wall in the sky. Part 3 ends with Antwerp saved, the V1 threat blunted, and the German high command baffled by how far American guns could reach. They were not imagining it. The 90mm battery was the first true automated anti-aircraft weapon system in the world, an analog ancestor of modern surface-to-air missiles. And yet, behind the mathematics, it was still men who made it work. The radar van shook in storms. The M9 jammed if dust slipped into its gears. Few setters froze in winter nights, turning dials with numb fingers. But when the system worked, and by 1944 it worked often, it turned the sky into a killing ground. Crews felt it too, a strange mixture of awe and fear. They were no longer guessing. They were no longer aiming by instinct. They were fulfilling the cold logic of a machine that told them where death must occur. One radar operator later said,
We felt like we had the future in our hands. We were shooting with math. Part 2 ends on the eve of the greatest test the 90mm system would ever face, the defense of Antwerp, the battle where American radar and steel would meet the German V-1 flying bomb in a duel that pushed physics, electronics, and human nerves to their limits. The Germans thought altitude and speed would protect their weapons. They were wrong. The 90s were about to prove just how far and how high they could reach.
By the winter of 1944, the war in Western Europe had entered a strange twilight. On the ground, Allied forces were pushing steadily toward Germany, but in the sky above Britain and the Channel, the struggle was far from over. The Luftwaffe, though battered and shrinking, still launched frantic raids, desperate attempts to slow the Allied advance, to strike ports, fuel dumps, convoys, and the great airfields feeding the war machine. And waiting for them, silent in their sandbag nests along the coastlines and cliffs, were the 90mm guns, now paired with radar and computers so seamlessly that pilots joked the Americans had electronic angels watching over them. The British night sky, wherever we flew, they followed. On the southern coast of England, the nights were long and bitter. The cold air off the Channel soaked through uniforms and into bone. Yet along the chalk cliffs, radar vans hummed like metallic beehives. SCR 584 dishes turned in slow, patient arcs, scanning the skies for the faint blip of an intruder. When the Luftwaffe struck, often at night, often alone or in small groups, the 90mm crews snapped awake instantly. There were no searchlights now, no guessing, no frantic scanning of the heavens. The radar locked, the computer calculated, the gens obeyed. A pilot of a Ju-188 bomber, interviewed after the war, remembered the fear clearly. We flew high, where searchlights could not reach, but always, always the black bursts came at our altitude, not below, not near, exactly where we were. It felt, he said, as if the flak was watching us. For the first time, the Germans faced a gun that did not care about the human eye. The 90mm operated with machine-guided certainty. Even above cloud layers, even in storms, the fire came. Me-262, the jet that could outrun everything, except math. In 1944, the appearance of the Me-262, the world's first operational jet fighter, shocked Allied pilots. It was faster than anything in the sky, capable of diving through bomber formations before anyone could react. But speed alone did not save it from the 90mm. Radar did not care how fast a plane moved. The M9 director did not get flustered. The math adjusted instantly. At a field near Dover, a battery of 90mm guns logged one of the first confirmed AA assists against an Me-262. The jet streaked in at nearly 500 miles per hour, aiming to strafe a fuel depot. SCR 584 tracked it in seconds. The M9 solved the necessary lead point, a point no human gunner could have manually calculated in time. 3 90mm guns fired simultaneously. Their shells detonated in a staggered pattern ahead of the jet's projected path. At that speed, a single fragment was lethal. The Me-262 punched through the cloud of shrapnel and immediately trailed smoke. It crash landed short of the coastline. The German pilot survived and was stunned. He said, "No gun should have been able to track us." But it did. The cross-channel shield, a web of steel and electricity. As the Allies built up forces for the final push into Germany, the channel became a vital artery. Troops, fuel, trucks, tanks, ammunition, all flowing from England to the continent. If the Germans had managed to disrupt that flow, the offensive might have stalled. But over the channel loomed a defensive network unlike anything in military history. 90mm guns on cliffs, piers, barges, and artificial islands, SCR 584 radars overlapping in wide arcs, M9 computers operating 24 hours a day, spotter posts relaying bearing and altitude instantly. At night, the scene was terrifyingly beautiful. The guns fired upward, their muzzles flashing white against the dark, shells arced into the void, detonating in silent blossoms far above the waves. The explosions reflected in the water like fallen stars. German intruders, UU-88, HE-177, and even the rare AR-234 jet bomber found themselves flying into a dome of perfectly timed fire. One British naval officer stationed at Dover Castle described the spectacle. "We could not see the enemy,
but we could see the sky light up over and over as the Americans' 90s walked their fire across the night. It was like watching the aurora borealis made of steel. The Luftwaffe's disbelief. Captured German documents from early 1945 show a tone not of confidence, but despair. Pilots complained that the Americans had found a way to make altitude irrelevant, speed irrelevant, clouds irrelevant. One report read, "Our night raids cannot approach within 20 kilometers of the defended zone without suffering catastrophic losses." Another warned, "The enemy's radar-guided artillery is operating at a level we cannot match. It is not flak, it is technology." Even more striking was the psychological effect. Luftwaffe crews spoke of flying in constant dread, never knowing when fire would erupt exactly at their altitude. Some called it ghost flak because they often never saw the guns, never heard the reports, only the sudden burst of fire around their cockpit windows. Holding the line during the Ardennes. When the Battle of the Bulge erupted in December 1944, weather grounded the Allied air forces for days. German bombers and reconnaissance plans suddenly had more room to operate. Or so they thought. In reality, the 90mm guns kept the skies contested even when P-47s and Spitfires could not fly. Batteries around Liège, Nîmes, and Spa fired blindly into fog and snow, guided not by sight, but by radar echoes. They shot down dozens of aircraft during the worst weather of the war. A German pilot described the sensation as being hunted by radar ghosts. Lessons written in the sky. By spring 1945, a consensus had emerged across Allied command. The 90mm system, SCR-584, plus M9 plus the gun, was the most effective anti-aircraft combination ever fielded in World War II. It had saved Antwerp, it had guarded England, it had made the Channel a deadly no-fly zone, and it had given the Allies something the Luftwaffe had once monopolized: air control through technology. The Germans feared Allied fighters, but they respected the 90mm. At altitude, it was the Americans' true power. Part 4 closes with the skies above Europe broken not by bombers, but by mathematics. The invisible hand that guided every 90mm shell to its mark.
When the guns finally fell silent in Europe, the 90mm batteries stood like monuments, steel silhouettes against a sky they had spent 2 years defending. Their barrels were blackened, their breech blocks worn, their radar vans dented from months of mud and storms. But they had done what few weapons in history could claim. They had turned the impossible into routine. They had hunted machines faster than any pilot, seen through clouds thicker than any searchlight, and struck aircraft flying at altitudes once considered sacred. The war in the air had been reshaped by a simple equation: radar plus mathematics plus steel. But the legacy of the 90mm gun did not end with the defeat of the V-1 or the collapse of the Luftwaffe. Its story continued in unexpected ways, first on the ground, then in the doctrine books, and finally, in the way future generations understood warfare itself. From sky killer to tank killer. As the Allies closed in on Germany in 1945, the battlefield shifted. The Luftwaffe was dying, its wings clipped by fuel shortages, pilot attrition, and the relentless precision of Allied air defenses. But the German ground forces still had teeth. The teeth of tigers, panthers, and Jagdpanthers guarding the approaches to the Rhine. It was here that the 90mm gun found a second life. Commanders had suspected for years that the 90mm's high muzzle velocity could make it an effective anti-tank weapon, but the urgent needs of air defense had kept it locked in its skyward role. Now, with radar-guided AA fire less critical and the push into the heart of Germany intensifying, the guns were reassigned. Crews dug them into concealed pits overlooking crossroads. Others mounted them on half-tracks or on ad hoc platforms. A few were even fitted into makeshift tank destroyers. The transformation was shocking. In live-fire tests against captured German armor, the 90mm punched through Panther front plates and even the sloped armor of a Tiger II's turret cheek at combat ranges.
The same shell that could burst into 1,000 fragments at 35,000 feet could also pierce 150 millimeters of Panzer steel. The gun's reputation shifted almost overnight, from guardian of the sky to slayer of giants on the ground. The U.S. Ordnance Department took note. Future anti-tank vehicles, including the famed M36 Jackson and the upcoming M26 Pershing, used the 90mm as their main armament. The weapon had crossed domains, proving that great design transcends the role for which it was born. A blueprint for the future, controlled warfare. The true legacy of the 90mm gun was not its power. It was the method. Before the SCR-584 and M9 Director, anti-aircraft fire had been a game of luck and eyesight. After them, it became science. For the first time in human history, machines could detect a target without visual contact, calculate its future position, adjust guns automatically, fire at a predicted point in space and time. The 90mm was not just a gun. It was the ancestor of the guided missile. Military theorists studying the Antwerp defense realized they were witnessing the birth of a new paradigm, one where weapons were no longer pointed by instinct, but by data. Decades later, the world would see that paradigm fully realized in surface-to-air missile systems, fire control radars on naval ships, jet-age interceptors using radar gun sights, automated AAA like the Soviet KS-19 and the US M51 Skysweeper, and eventually guided rockets, Patriots, and digital air defense networks. Every one of them owed a conceptual debt to the 90 plus SCR-584 plus M9 triad, the human legacy. Yet, beneath the technological triumph lay the quieter legacy of the men who served behind the machines, the radar operators who stared at green screens until their eyes swam, the gun crews who froze through Belgian nights, setting fuses with numb fingers, the officers who balanced math and instinct as they commanded networks of steel and electricity. Many never saw the aircraft they shot down. Some never even heard the explosions, only the numbers. They fought an enemy measured in bearings and frequencies, not faces. After the war, some of these men became engineers, others taught physics. Some went home and never touched a circuit again. But all carried the memory of a strange, modern kind of combat, a war fought between invisible machines, invisible signals, and invisible moments of life and death. One radar man described it decades later. "I didn't shoot at airplanes. I shot at predictions." Respect from the enemy. German pilots, too, remembered. Interrogation reports from 1945 contain a recurring sentiment: awe. One ME-410 pilot said, "Your flak chased us into the clouds." Another wrote in a private letter, "It was like the Americans had turned mathematics into a weapon." And a German Luftwaffe officer responsible for V-1 operations admitted, "We thought altitude would save us. We were wrong." Respect in war is measured in losses, and the 90mm gun earned the enemy's respect the hard way. The final image. In the spring of 1945, as victory drew near, a 90mm battery outside Antwerp was ordered to stand down. The radar van powered off with a long electronic sigh. The guns were lowered for the first time in months. The crews gathered around them in silence. Above them, the sky, once filled with the drones of V-1s and the thunder of enemy bombers, was empty, clear, quiet. One sergeant reached out and tapped the cool metal of the barrel. "It reached higher than any of us ever thought," he said, "and it saved more than we will ever know." The others nodded, because they understood. The war might have been won on the ground, but part of victory had been written in the quiet, invisible, mathematical fire of the 90mm guns. The Germans believed altitude was safety. The Americans proved altitude had a limit, and the 90s reached it.